All right, welcome back, everyone. Just give it a few more minutes. Wait for everyone to trickle in, and then we'll get started. All right, how's everyone doing today?
Bro, I accidentally paid $8 for Hulu.
Pretty good.
Pretty good. All right. Anyone do anything fun today? We gotta enjoy our summer. Wow, summer only happens once a year. All right, we'll wait for a couple more people to come in, and then we'll get started.
Yes.
Hopefully you can enjoy our bad joke of the day while we're waiting for people to come in. Come. All right, welcome everyone. Welcome back. Glad to see people actually came back. Can you guys hear and see me okay? Just wondering. I taught one class half an hour ago, and we had some camera issues. So, all right, admit. Let's see, we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. All right, someday I'm gonna hit the wrong button by accident. Someday I'm gonna hit deny all instead of accept all by mistake. All right, it's about 8:32. We'll get started. If anybody trickles in, I'll send them in this way. Welcome back, everyone. We're glad to have you all back, and good to see we still got all of you. Everybody have a good day so far? All right, looks good. As always, if at any point, oh, something pop in the chat. If at any point in class you want to say something, mention anything, ask anything, please feel free to unmute and speak straight to me. You could put it in the chat, but sometimes if it's in the chat, it's hard for me to see it when I'm working up here on the board. All right, so usually we start class by reviewing the material we did last class briefly and then going over the homework problems. But today, before we do that, I want to take a quick detour real quick. And I want to show you guys a quick trick from psychology that'll help you guys with your studying when you're in AP Chemistry next year. So let me just share my screen real quick. All right, it's going to go weird for a second, and it's sharing. All right, can you guys see what I'm looking at? Someone unmute and tell me.
Yes. We can see it.
All right, this is from psychology. This is the forgetting curve. And this explains why we study the way we do. So as with any graph, we're going to have to read a graph. Nobody likes doing that. The first thing we always do is we're going to look at the x-axis. We see on the x-axis, we have days. Days since we learned the material. On the y-axis, we have retention, and we see it's in percentage, which means the percent of information that we actually remember from class, which is why we call this the forgetting curve. So if we look at the curve here, you see how up here, can you see where I'm hovering my little cursor? Wait for someone.
Yeah.
We can see it. Up here, we're at 100% retention, which means that this is where we're sitting in class. We're actually sitting, learning the material. We understand 100% of it. So the material is 100% retained. Notice how after just a day, the amount we actually remember declines. So we went from understanding and remembering 100% of the material down to only about 60% after 1 day has passed. And that's because your short-term memory can only hold 7 to 9 items. So even though you understood the material in the class, you're going to forget it anyway because your brain's going to get rid of what it deems as unimportant. So your memory drops from 100% to 60% after the first day. But notice how up here you see this dotted line? This means we study. If we study the material after 1 day, notice the curve shoots back up to 100. So if we study the material again the day after we learn it, instead of only remembering 60% of it, we can actually boost our memory back up and remember 100%. And notice how after that, if we don't study for another day or two, the curve still drops. It still drops, but it doesn't drop as much as if we had not studied the first day. It drops less than it did the first day. So that means a day or two after that, we study it again, and it jumps back up to 100. We remember 100% of what we originally learned. And then notice here, once we study it for 3 or 4 times, you see how the curve still levels off, but it doesn't drop to 0. You see how it doesn't drop to 0 after we study it 3 or 4 times? Versus if we didn't study it at all, after a day or so, it would drop to 0. We would forget all the information. So that's why, at least when you take AP Chemistry next year, it's so important for you guys to not only understand the material in class, but you guys review it the next day, and the day after that, and the day after that. And each time you review it, you're less likely to forget it. And by the time you review it for the 5th time, like up here, even if you don't review it for days and days and days, you'll still remember 90 or so % of it. And that's how you retain the information in these classes with a lot of content. Do we have any questions on that? I know that was kind of a rant, but I thought it was just kind of interesting to incorporate a little psychology into what we're doing here. All right, so a couple quick announcements about from last time. So the homework, I saw a few of you submitted that on Classroom, and I got to take a look at it. If you didn't, I would highly encourage you submit it straight in that assignment from lesson 1 that I posted. I will post the answer key to the homework we did last time, just so you guys can double check your work and make corrections, because what's the point if we do the problems if we get them wrong? So it just helps reinforce the material. Next week, 4th of July week, there is no class. No class next week. So there's no meeting on Monday. There's no meeting on Thursday either. And the reason being is I know that 4th of July, a lot of families like to go on vacation. Go on vacation. Don't worry about coming to the meeting. There's no meeting next week. Instead, I will post a packet on Monday, which has a very fast assignment. It's like a 5-minute video I recorded on polyatomic ions. And then there's going to be a couple of practice problems from what we did last time and what we did today. Just because the stuff we do today, we continue to build on after July 4th. So it really helps reinforce that material we learned. Kind of like what we just talked about with the forgetting curve. We're constantly repeating it and getting better at it, so we can't forget it. Let's see. I did take a look at the surveys that I sent out last time about my teaching. I did take a good look at every single response that came through. Some of you requested that I incorporate videos when I teach. Some of you requested I use a whiteboard, and I'll try to accommodate those changes so that you guys can learn better. And if you didn't fill out the survey yet, it's still open. So I do encourage you to send it through so I can improve my teaching and improve the way that you guys learn from me. One last thing. I know some of you signed up for this class through me. You sent me an email or text and I added you to my spreadsheet. Some of you joined through just the Google Classroom link. If you join just through the Classroom link, please send me an email or send me a ping through Google Classroom with your email, your personal and your school email. That's just because there's another teacher that takes over after week 4. So when I send all the emails over to him, I have to make sure I get all of you guys over to his section of the class. All right. Any questions about that? No, I talked kind of quick. All right. So we're going to go over the homework from last time. So if we can pull out our little packet. Now, I'm going to do something a little different while you guys are taking that out. I am actually going to, since the problems we're doing today require a lot more board space, and I don't have a lot of board space on the blackboard. Hopefully you guys got to enjoy the bad jokes I put on. I'm actually going to switch Can you see me? Okay. Oh boy.
Mic's broken.
Turn your volume all the way down.
All right. Can you see me all right?
Nah.
Yes.
All right. I'm going to be using a sheet of paper today. Hold on. Oh, here go the thumbs down.
Who is Julie?
I'm going to be doing the class this way. Can you guys see the sheet of paper? See my hands all right? I know this is the old way of doing it.
If you got anything on, I can't see.
No, there's nothing on it. It's just a book.
Okay.
All right, let's see. This is how I taught last year. Let's see if it works now. All right, so we're going to go over the homework problems. How did the homework go? Was it too easy, too hard? Okay. All right, so I'm not going to go over all of them, but I'm going to do just a few so we get an idea. Let's see. Let's start with problem 1. So we have 25 grams of SbCl3, and we want to find how many moles. So how many moles? And we're given the molar mass is equal to 228 grams per mole. All right, does someone want to walk me through how to do this? Maybe I'll do the first one and then someone can walk me through the second one. So we have 25 grams of SbCl3. And from the ratio, we know that for every 1 mole, we have 228 grams. And we have to arrange that so that the grams cancel out. So we're going to put 228 grams on the bottom and 1 mole on top. The grams cancel out, and we're left with 0.11 moles of SbCl3. And that's our final answer. Any questions on that? All right, let's look at question 3. We're given that we have 2.5 moles of CO2, and we can want to convert that to grams with the molar mass is equal to 44 grams per mole. And can you guys see the writing okay? Is it clear enough? All right. So does someone want to walk me through how we're going to start this? Anyone, don't worry, don't be shy.
I guess I could do it.
Sure.
So if you're looking for how many grams are in 2.5 moles, and there's 44 grams in every mole, you can just multiply 44 by 2.5. 44 by 2.5. Do we agree? Disagree? That's good. Yep. So we have 2.5 moles of CO2. And we know that for every 1 mole, there's 44 grams. But then now we want moles to cancel. So the 1 mole has to go on the bottom, and then 44 grams has to go on top. Moles cancel out. We plug it into our calculator, and we get 110 grams as our final answer. All right. Let me just go run and grab a calculator so I can do the math. All right, now we're going to take a look at the next question. This is question 7. Which weighs more, 1 mole of magnesium or 1 mole of helium? And you guys might have had time to think about this, and I might not have mentioned this last class, but when we look on the periodic table, we see magnesium here, and we see helium up here. What I forgot to mention was the farther down you go, the periodic table, the farther downward, the bigger each atom is, the heavier each atom is. So we remember that moles counts by the particle. So if we have 1 mole of this and 1 mole of this, they're the same number of particles, but since 1 molecule of magnesium is heavier, the 1 mole of magnesium is heavier. All right, and then finally, 2 last problems, problem 8. These ion problems, I know, give a lot of people trouble. So write the compound formula when Fe bonds with O, and we're given Fe has a +3 charge. Oxygen
We look up on the periodic table. It's right here. We look up. It has a -2 charge. We crisscross the two, and we get Fe. Hold on. Fe, and there's a 2 here and a 3 there. Any questions? All right, and then question 11. This is the harder version. We have Ca3P2. Write the ions once they break up. This is the harder one. We have to crisscross backwards. So we get Ca plus 2 and P minus 3. But this is the part a lot of people forgot. We got the right ions, but we have to make sure they balance each other out. So when we look at the starting material, this 3 under the Ca means that there's 3 molecules of Ca. It tells us how many molecules there are. So at the end, we have to throw in the 3 on the Ca and the 2 on the phosphate. And this is our final answer. Any questions on that? I'm sorry I went through that fast. All right, ready to learn some new stuff? So let's
Yes.
Oh, someone say something? All right. Do apologize.
I like that picture.
What? Oh, you don't like the tablecloth?
Nah,
Eh.
no. I'm not talking to you.
No.
Aaron,
I don't like that picture.
Let's save this for after class, Kevin. Oh, and in case I haven't mentioned, Kevin is my brother. So don't be offended if I make fun of him during.
You're late.
Okay, so let's take out our template that I sent this morning. Today we're going to talk about chemical equations and balancing. So if we look at this formula that I wrote, 2H2 plus O2 goes to 2H2O. We're going to have a little anatomy lesson right here. These two things on this side, these are called the reactants. This thing here is called the product. The chemical formula tells us we start with something, we go through a reaction, and then we end with the product. So it's always left side reacting goes to the right side. Ooh, someone else wants to join the call. All right.
Oh,
I hope my...
Oh, yeah.
All right, so if we look at these numbers here, you see how there's some numbers in front of the number and some numbers below? The numbers in front, these are called coefficients. And I'll just abbreviate that.
For your information, I also was hitting a hoop.
The numbers down here are called subscripts. And that does make a difference when we do what we're doing later with balancing. Any questions?
Yes.
No.
All right. Thank you for the confirmation. Now, I'm going to pose a question to you guys. This is 2 hydrogens, 2 H2s, mixing with oxygen to make 2 molecules of H2O. The coefficient tells us that there's 2 of this entire molecule. So 2 H2O molecules, water. So why don't we, let me ask you guys, why don't I just write the equation like this? We have hydrogen, we have oxygen, they're coming together to make water. Why can't I write it like this? Because this is wrong. Why can't I write it like that?
Aren't you missing an oxygen?
Exactly, we're missing an oxygen. The numbers of the atoms on the left side don't match on the right side. On the left side, we have 2 oxygens, but on the right side, we only have 1 oxygen. So that brings us to one of our important properties in chemistry, balancing. Mrs. Simsick and Mrs. Battaglio, balance. No, I'm just kidding. I'm just kidding. Please. So what that means is,
Scale's gonna be like weighed down a ton.
Okay. All right. Let's pretend we didn't make that joke. So now we have balancing. And what that means is the atoms at the start have to match the atoms at the end. So I'll write that atoms at the start must equal atoms at the end. Which means the number of each one stays the same. So if we start with 2 oxygens, we must end with 2 oxygens. And what this means is when we write chemical equations, we have to make sure that they match. Which here comes the annoying part. Let's look at the first example, which I'm going to have to write out, which is going to take some time. How are we doing so far? Am I boring you guys to death? All right, so let's look at this. I personally don't like these problems, but we have to learn them anyway. So when it comes to balancing equations, here's the rule. We can only change the coefficients, the numbers in front of the molecules. We cannot change these little subscript things. All right? And the way we do it is we literally guess and check. We throw a number in here and see if it matches the ones on the end. So what happens is we have to calculate out how many of each atom we start with and how many we end with. So if we look on the left side, so let's say we're looking at the left side, how many AGs do we start with?
Can you pan the camera left slightly? I can't really see it all.
Move the camera to the left.
Or the paper, yeah.
One.
We have 1 AG, right? But how many AGs do we have on this side?
2.
2, right? All right. So we need to fix that. So what we're going to do here is, in general, it's easy to start with the most complicated thing, but that's not always the case. But we know that we need another AG on this side, and there's no other there's no other molecule with AG in it, so we're going to throw a 2 in front of this. But oh shit, look, now we have 2 AGs, but what did I also mess up? Now I messed up the eyes, right? Now I have 2 eyes on the left side and only 1 eye on the right side. So I have to throw in a 2 right here. But now look what I messed up. Oh, nah, now I messed up the NAs. Right now there's 2 NAs. But wait, I look on the left and there's 2 NAs miraculously because God was looking out for us. So let's make the circle. Let's hold them hands. And also, no, wrong context. Anyway, we see how it's balanced now because each side of the molecule has 2 AGs, 2 I's, and then 2 NAs and 1 of the S's. So that's how balancing works. You start with the most complicated thing, you add in coefficients, and then you add to the other side to make it balance again, and then you keep going until something works. Any questions on that? Okay, I'm going to give you guys a problem to try. This is the next one on your sheet. Try to balance this. I'll give you guys a couple minutes. I don't like these problems, so and they're not that important, so we're not going to do them too much. But we are going to do them. Can you guys see the whole thing? Okay. All right, give that one a try. And let me know if you have any questions.
Nah, you can't. Wait, yo, get in the screen. Yo, get in the screen. can.
Justin, do we write a 1 if we don't change anything?
I don't think so.
Shut up, Kevin.
Bruh,
I'm asking Justin.
Justin's on his way back now.
Oh my god.
All right. Does anybody have an answer yet?
I got it. I think.
Is it?
I got no. I got 2 NaBr plus 1 Cl2 equals 2 NaCl plus 1 Br2.
All right. Does anybody agree?
I agree.
Thank you.
All right. So we look at this. We see there's 2 CLs here and only 1 CL here. So you need to throw in the 2. And then we fixed the Cl, but we messed up the NAs, the sodiums. So we have to come over here and add the 2 in. But then now we messed up the BRs. But we look over here and there's already 2 BRs because God was looking out. I'm just kidding. Anybody who's atheist out there, I'm sorry I offended you. Anybody who's religious too. This is not a family class. Oh, and by the way, with these balancing problems, the answer is not always 2. Just putting that out there. So in AP chemistry, it doesn't mean just write 2 for everything. Any questions on that before we move on?
No.
All right. Thank you, Aaron. Next, we're going to talk about stoichiometry. Stoichiometry. This is very similar to what our homework did. We did on the homework. On the homework, we went from grams to moles of a single molecule, which took 1 step, right? It took 1 step to convert between grams and moles. Today, we're going to do problems that require 3 steps of conversions. Oh no, the sky's falling.
You a bitch.
Hey, that was unnecessary.
Hey.
All right, so here's the thing. What is stoichiometry? Stoichiometry is all about ratios. All right, so now let's say I'm going to explain why and what it means, but you guys are going to have to trust me for a second, all right? Let's say we have this formula. SO2 4H2O. The key to stoichiometry and the reason we have it is that once we have a balanced chemical equation, if we look at the numbers, the coefficients in front of each one of the molecules, that actually tells us the ratio of the number of moles. So I'll write that up here. The coefficients in the balanced chemical equations are used as ratios. What does that mean? What the hell does that mean? This means that if we know that we have 1 mole of C3H8, we know that we have 1 mole. We also know we have 1 mole of SO2. We also know that we have 3 moles of CO2 because there's a 3 in front of the CO2. We look at the coefficients. And we also know that we have 4 moles of H2O. So why do we care about this? Because if we know the amount of one thing, then we can use the formula to find the amounts of any other thing using the ratios. Does that kind of make sense? So we got all of this information just by looking at the numbers in front of the molecules, and that's what makes stoichiometry so powerful. Now, how does this come into play when we're actually doing problems? So let me show you guys real quick. Let's see. The first part. First moles. All right. So we have 1.2 moles of H2O. How many moles of CO2 do we have? Oh, sorry. Never mind. That's question 2. We have 0.8 moles of SO2. And there's a typo on your sheet that says CO3. It's really supposed to say CO2. So just change that real quick. All right. So last time when we did the homework, we went from moles of one thing to grams of the same thing. Now we're going from moles of one thing to moles of something completely different. Notice we're starting with SO2, but now we're going to CO2. That's different from the homework because on the homework, we went from moles of SO2 to grams of SO2, but now we have to cross over to CO2. Here comes one of the rules. Before you switch from one thing to another, you must be in moles. So you must use moles when you switching between molecules. All right, now let me show you what this means. So we start with 1.2 moles of SO2, right? And we want to get to CO2. That's our goal. We want to go from SO2 to CO2. Which means we have to take this and we have to multiply it by one of these ratios so that the moles of SO2 cancels out. So we know that for every 1 mole of SO2, we have 3 moles of CO2, right? For every 1 mole of SO2, we have 3 moles of CO2. So we're going to put 1 mole of SO2 down here, and we're going to do 3 moles of CO2 up here. We plug that into our calculator, and we get 2.4 moles of CO2. Oh, sorry, this is supposed to say 0.8. I was looking at the wrong problem. 0.8 moles of SO2. So if we look here, this is a bridge problem. You see how we use the moles and the coefficients in front of the molecules as our bridge to get from SO2 to CO2? Any questions on how I did that? That's going to be really important when we move on. All right, let's go to the next problem. And no questions at all? Oops, smart class. Or I'm not that smart. It's probably the second explanation. Okay. Now this is why we're moving on to the next problem. So we have 1.2 moles of H2O. And we want to find out how many moles of CO2 do we have? So we always start with what we have, 1.2 moles of H2O. But now we need to multiply it by that bridge. Build the bridge. And we know that for every 4 moles of H2O we have 1 mole of CO2. You see how there's a 4 in front of the H2O? And there's a 3 in front of the CO2? So we look for the ratios that connects the problem. So we multiply by 4 moles of H2O and 3 moles of CO2. We plug that into our calculator. We get 0.9 moles of CO2. Any questions on that?
Can you explain the ratio thing again? I kind of dozed off.
Yeah, so we needed to find, so we start with moles of H2O, and then we have to get to CO2. But then now we have to find the bridge. that converts moles of H2O to moles of CO2. So we look at our chemical formula, and you see how there's a 4 in front of the H2O, and there's a 3 in front of the CO2? That tells us that for every 4 moles of H2O, we have 3 moles of CO2. So we use that as our ratio, and we arranged it so that the moles of H2O cancels itself out. You see how moles of H2O just cancels out, and it leaves us with moles of CO2? That's how we did it. Does that kind of help clarify?
Yeah.
This is the hardest part for anyone starting chemistry for the first time, which is why we're doing it today. You're going to have some homework, and all of next week, we don't have any class so that you guys can review the problems and do new problems to get used to this, because this is important in chemistry. Anyone else have any questions? I like when kids ask questions. Anyone else? All right, let's look at the next problem.
Wait. For like the one before we said that like the 0.8 SO2 times like the 3 mole CO2 over 1 mole SO2. How'd you get that ratio again? Like because like I don't.
Oh, go ahead, finish your question.
Because I thought they had to be on like the same side of the equation.
They don't have to be on the same side. You can use ratios from any of the two sides.
Okay. So you can just like make ratios with any of the reactants and products?
Yep. As long as you look at the coefficients. And actually, yeah, we'll keep it at there for now. It's gonna get a little complicated after, but then for the now we'll keep it like this. But remember, every time you want to switch from one element to another, anytime you want to make a ratio, you have to be in moles. You cannot go grams to grams. You have to go moles to moles. All right, are we ready for the next problem? Will you take another quick second to digest everything I just said? Getting harder, right? Honors Chem kids, CP Chem kids, they spend like 2 months on this. AP Chem, you spend 2 days on this. All right, so same equation. This time, we start with 0.5 moles of C3H8. And we want to find how many grams H2O. Oh, crap. Great. This is different. Okay, so let's say we're sitting on the chemistry exam. We forgot how to do this. Oh, terrific. Great. I'm going to go to MCC now. No, I'm just kidding. I took classes at MCC, so I didn't mean to offend anybody.
Hey, my mom went to MCC.
Yeah, me too. I went there too.
Come on now.
I did not mean to offend anybody. So we have, what we do is if we forget what to do, we have to first start out by just remember, these problems, you want to get to moles first. So we start with 0.5 moles of C3H8. So we're in moles already, so we're in good shape. Are we ready to make our bridge, to make our ratio?
No.
We'll just fold this. Yes, right, because we're in moles. All right, so let's do it. We're at CH. Can I just say CH? Forget the numbers so it's easier to say.
No.
We're at CH and we want to get to H2O. All right, what's our ratio going to be? Anyone want to take a swing at it?
4/1.
4/1? Do we agree? Disagree? Yeah, because there's 1 CH for every 4 H2O. And we have to now all we have to do is arrange them so that the moles of CH cancel out. So we have 1 mole of C3H8. Remember, because there's a 1 up here. And then 4 moles of H2O, because there's a 4 up here. All right. So Moles of CH cancel out. Good. So now we have moles of H2O left. But we're not done yet. We're not done yet because it wants grams of H2O. But we got one step closer. So at least if we're on the exam or Mrs. Powell's test, at least we got partial credit. Which is why we leave it and then we move. No, I'm just kidding. All right, we want full credit though. So what happens here? We're in moles of H2O and we want to get to grams of H2O. Do you see, notice how next to the problem I gave you the molar mass of H2O is equal to 18 grams per mole?
No.
This is exactly what we did on the homework yesterday. We have moles of H2O and we want to get to grams of H2O. So we have to use the molar mass as a ratio and we have to arrange the units so they cancel out. So we're going to put moles on the bottom, 1 mole of H2O on the bottom, so it cancels out, and 18 grams of H2O on top. We punch this whole thing into our calculator. 0.5 times 4 times 18. And that gives us 36 grams of H2O. Any questions on that? Getting hard, right? Give me a thumbs up, thumbs down, thumbs to the side. How are we feeling? Thumbs up, good?
What if you did the? What if you flipped the 18 grams into 1 mole?
If I flipped it
Yeah, because aren't they like the same thing?
they're the same thing when they're on their own. On its own, it just equals 1. But in this, it actually matters that the moles has to go on the bottom. Because you see how we want the moles of H2O to cancel out, so we're left with grams of H2O?
Yes.
Yeah, so in this case, it does matter what goes on top and on the bottom.
Julie, stop spamming emotes.
All right. Anyone have any questions before we move on?
Did you do the bottom question or the second to bottom question?
The second to bottom question. Ready to move on?
Yes.
All right. Let's see. Maybe I'll rewrite the whole thing so it's clearer. You guys are doing awesome. I know this is fast, but you guys are great. You guys are better than me. You guys are smarter than me, and you guys are gonna crush this class next year and this.
Please stop spamming emojis.
All right, so now the last question. This is going to be a very common question that we have to get used to, both for the summer session and for AP Chemistry. We have 1.5 grams of SO2.
Bro.
How many grams of H2O do we have? Oh, boy. Let's take this one step at a time. When you see something like this, and I'm going to give you a hint, our little memory trick. When you see we start with grams and we end with grams of something else, here's the order we do them in. We go grams to moles to moles to grams again. We cannot go straight from grams to grams. We have to use moles as the bridge. So let me talk you guys through this. We have 1.5 grams of SO2. We want to get it into moles of SO2, right? Because we have to be in moles before we make our bridge. That's the key here. I'll say it once, I'll say it again. We need to get to moles in order to make a bridge. And then we're given that the molar mass of SO2 is equal to 64 grams per mole. So now we have to get this into moles of SO2. So we need a ratio. Anybody want to guess what the ratio is?
Is it 4/1 again?
Not quite
Or
yet, because our goal is to get into grams. We need to get into grams of SO2. So we need molar mass.
Is it 1 mole of SO2 over 64 grams of SO2?
Exactly. Do we understand how we got that? 1 mole of SO2 divided by 64 grams of SO2. Because the molar mass says for every 1 mole we have 64 grams. And we want the grams of SO2 to cancel out, so we put the grams on the bottom. So that cancels out. Now, we're in moles of SO2, right? Is it time to make our bridge yet to use those ratios? We can make the ratios now, right? Because we're in moles. So we're starting with SO2, and we want to go into H2O. So we notice there's a 1 in front of the SO2, and there's a 4 in front of the H2O. So like Aaron said, now we're going to do the 1 to 4. We want moles of SO2 to go away, so we're going to put 1 mole of SO2 on the bottom. Remember, the 1 came from the balanced equation. There's a 1 in front of the SO2. And then 4 moles of H2O goes on top, because there's a 4 here. That's the bridge. And what does the bridge mean? It basically means we're switching molecules. So that's what we did. We swapped molecules. We got from SO2 to H2O. Now, we want to get into grams of H2O, right? And we're given that the molar mass of H2O is equal to 18 grams per mole. Do you see where I wrote that on your sheet? So now we're finally in moles of H2O. To get to grams of H2O, we use the molar mass. We have 1 mole of H2O times 18 grams of H2O. And do you see why I put the moles on the bottom so the moles of H2O cancel out? So once I put all of this into the calculator, so 1.5 divided by 64 times 4 times 18, I get 1.69 grams of H2O. That's as complicated as it gets. Any questions on that?
is this like a hard question or like is it a simple one? So
This is, I don't want to scare you guys. This is the harder question for a CP Chem class, but this is the easy question for AP Chem class. So for a CP class, this would be considered a hard problem. But for AP Chem, this is probably the easiest problem on the exam.
Can I drop out?
Well, that's up to you. I'm just the teacher here. I'm just the messenger. Any questions at all about how I did these numbers? I know it's a lot. So we went from grams of SO2 to moles of SO2 to moles of H2O to grams of H2O. That's why I said grams to moles to grams here. But do you see how the whole purpose of the mole was to make that bridge in the middle? That's the whole purpose of moles, is to get us from one thing to another, one molecule to another. All right, I'm going to show you guys one last thing about stoichiometry, and then we're going to go straight into our practice session with the worksheet. Are we good, or do we need a minute to process everything?
I think Kevin does.
I care about you guys. Yeah, let me know if you need like a quick minute break or so. I don't want to overload you guys. That's what AP Chem is for. It's come to think of AP Chem, it's not that it's super well. It's hard, but what makes it hard is the speed that you learn everything. Like in AP Chem, I think Miss Powell taught that in like 10 minutes, which I went in and I'm like, oh my god, this class is. Yeah, and it went on like that all year long. She's a good teacher, but it's just the speed of AP Chem is just brutal. Unlike Miss Belleville. Belleville was not a good teacher. I will say that openly.
Justin, there's 10 minutes left.
I hear you. All right, this is the one last thing we're doing, all right? So on the next page, you see the page with the car?
Yes.
Stoichiometry with subscripts. Remember the difference between a subscript and a coefficient?
Subscript is the number on the bottom, and
Yeah,
coefficient.
so coefficient was the number in front. Subscript is the little baby number in the bottom, right? What we just did earlier was stoichiometry using the coefficients. But what happens is we can actually do stoichiometry using the subscripts too. So what do we do this for? We use this when we're going from molecules to atoms. When we break molecules into their atoms, we use the subscript. Exclamation point. And now, why do we do this? So let me explain. Let's say we have the molecule C2H4. What that looks like is this. We have 2 carbons and then 4 hydrogens. So one of these looks like that. Literally, it looks like that, if you guys ever take organic chemistry. So if we have one C2H4, if we have one of those, we know that we have 2 carbons and 4 hydrogens, right? Because one of these whole things has 2 carbons and 4 hydrogens. Likewise, if we have 1 mole of C2H4, we know that we also have 2 moles of carbon and 4 moles of hydrogen, right? Because if we have 1 mole of this whole thing, that means we have 2 moles of carbon because there's 2 times as many carbons as this whole thing, and 4 times as many hydrogens. Therefore, we can turn this into our ratios. 1 mole of C2H4 over 2 moles of carbon, which equals 2 moles of carbon over 1 mole of C2H4. You see how I used stoichiometry just like earlier? So let me do an example problem. We have 1.7 moles of C2H4. How many moles of carbon do we have? Question mark. So we start with 1.7 moles of C2H4. As always, when we're making a bridge or whenever we're doing ratios, we have to be in moles. We cannot do this using grams. So if we are in grams, we got to get to moles. However we do it, we got to get to moles. So we know that if we have 1.7 moles of this, for every 1 mole of C2H4, we have 2 moles of carbon. Right? Because one of these has 2 carbons in it. Are we good with that? So we plug this into our calculator, 1.7 times 2, and we get 3.4 moles of carbon. Any questions? Last problem I'm doing in front of the class. I know the class is about to end. So we still have our worksheet, our practice worksheet that we have to do. I'll send out an extension link after this, but after this problem, the lecture portion is done. So I'm not teaching anything new after this. We're just doing the practice worksheet on the back, and then I'm going to go over the answers. So if you can stay for the extension, I'd highly recommend it so we can do the problems out. But if you have to go to bed, you have other commitments, I totally understand it, all right? But I'm here. I'm here until, we finish. All right, so next problem, last problem of today. We have 0.6 moles of C2H4. How many grams of hydrogen do we have? And we're given that the molar mass of hydrogen equals 1 gram per mole. Okay. So I forgot to mention earlier, the whole reason that we're breaking these things up here is like, I had an analogy on the sheet that I forgot to mention. Stoichiometry with subscripts is kind of like grand auto theft. We're breaking up a car. Because would you agree that if we have one car, we have 4 tires? Similarly, if we have one molecule of C2H4, we have 4 hydrogens. That's just an analogy. One car has 4 tires, and one of this whole thing has 4 hydrogens. All right, so we start with 0.6 moles C2H4. We want to get to moles of hydrogen, so we need to make a ratio. And there's a number 4 here, 4 hydrogens. So does anyone want to give me a shot, give a try? What's the ratio? It's okay if it's wrong. I got it wrong first time.
Is it 4 to 1?
4, let me see. Yes, 4 to 1. What goes on top? 4 or 1?
The 4 goes on top.
4, right? The 1 goes on the bottom because we want the moles of C2H4 to cancel out. And the 4 goes on top because we want to keep the moles of hydrogen. So the moles of C2H4 cancel out. So we finally got 2 moles of hydrogen. But we want grams of hydrogen. So we need to use the molar mass. And we have to arrange it just like we did on last night's homework so that the moles of hydrogen cancels out. So we have 1 mole of hydrogen on the bottom is equal to 1 gram. And the moles of hydrogen cancel out. We plug this all into our calculator and we get, our final answer is 2.4 grams of hydrogen. Any questions on that? The meeting's going to kick me out, unfortunately. But I will send an extension link for the practice worksheet session. I will stay on here. I would recommend you stay, at least do a couple problems, get the hang of it, so we can go over it. But then you guys are free to go when you guys want, all right? So any questions on this? I know I just threw a lot at you. But I hope it... Give me like a thumbs up, thumbs to side, thumbs down. Got it? Of course, Kevin is thumbs down. Oh, my algebra kids are still here? Wow, I give you guys credit for sitting through chemistry like that.
Wait, so I was saying all that stuff and it's a bunch of like 5th graders here?
Yes, yes. My algebra students asked earlier if they could sit into chemistry. I said, sure, go ahead. I told them I talk a little differently in this class, though. Hello, hey. Wow.
Can you kick them out?
Huh?
Can you kick them out?
The meeting's going to kick me out. It's going to kick us all out. But I'll get the link, and then you guys can join back if you want.
Justin, it's past my bedtime.
All of our bed. There's no bedtime in college.
Alright, what kind of name is Hui? Hui.
What the fuck? Yo, if you're watching this, some good food I'm eating, bro.